always seem to have a little bit of trouble with inverse trig functions. So first we'll start with a quick review of our basic trig functions, which are sine. Let's see, well, let's go ahead and draw a right triangle first, actually. So we'll put that guy up there, and then we will talk about the three trig functions: sine, cosine, and tangent. And we use our little acronym. Oscar had a hunk of apples. And what the heck does that mean? Well, in terms of a right triangle with an angle theta, we'll call this angle here theta, then we have our sides relative to theta, and the opposite side would be the side that's opposite to our angle. So this would be the opposite side. We usually label that OPP. And then we have the adjacent side, which would be here, adjacent. And this side over here is also adjacent, but this side is special because it's the hypotenuse. So we'll go ahead and label this guy the hypotenuse, which leaves the only adjacent side to theta being here. Now, another way to look at this would be, let's take another right triangle. Let's make this one blue. So we've got our classic right triangle like this. I'll make them a little, and there. And then we'll put theta over here. We'll just put theta. We'll call that one theta. Let's make him theta. So here's theta. Okay, so this being the right angle, that makes this the hypotenuse. And adjacent is right here. Adjacent. And the opposite here is right here. So that's where the Oscar had a hunk of apples. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And let's be a little more clear here that these are equal to these ratios. So the sine of theta is opposite over hypotenuse. So what does that give us? Well, if we put an angle like 45 degrees in, sine of 45 degrees is the relationship of the opposite side to the hypotenuse. And usually we look at the hypotenuse as being a length of 1, just for convenience in our unit circle. So let's take a look at some of the mathematical perspective here. The sine of 90 degrees. Okay, what is the sine of 90 degrees? And we have to use the word degree here, which actually has a mathematical meaning, because Mathematica uses radians primarily. So if you're not using radians, you have to say degree. So we're going to go ahead and evaluate that, and the sine of 90 degrees is 1, and that's what your calculator would give you as well. The cosine of pi over 4, that's radians, so we don't have to say degrees, is 1 over root 2, and we usually express that as root 2 over 2. The tangent of 45 degrees is 1. Now, why is the tangent of 45 degrees 1? Well, let's go back and look at that. So if we have a right triangle, let's take a right triangle here and make a 45 degree angle. That's not very good, but you get the idea. If this is 45 and this is 45, and this is 90, that means that this is an isosceles triangle. It looks more like a wizard hat or something, but we have our situation here where that means that this is congruent to this, And that means that the ratio, which is the tangent of Oscar had a hunk of apples. Okay, so either one of these can be theta. So we'll call this theta. So opposite over adjacent. So if this is equal to this, it doesn't matter what these values are. They're going to be, the tangent of theta is going to equal something over something. We can call that something x over x, which is going to equal 1 no matter what. So that's the case of the tangent, and I should be writing in theta here, tangent of theta. Okay, so where does that leave us with inverse trig functions? Well, inverse trig functions, as you saw in the Mathematica screen, are written as arctangent, or sometimes you see them as tangent inverse. Okay, and this could also be sine inverse, cosine inverse, and that is the same as arc sine, and this is the same, of course, as arc cosine. I don't really care which one you use. The only problem with using this format is it looks a lot like an invert when we use the inverse of a number, like 2 to the negative 1. Well, you all know that equals 1/2, or 1 over 2. Pi to the negative 1 is equal to 1 over pi. So the danger of using this is some people think that the cosine inverse of, say, 7 is equal to 1 over the cosine of 7, which is not true. It's not equal to the cosine of 1 over 7. It's actually just a convenient notation that represents that this is an inverse function, not actual physically inversing or inverting the number. So don't do that. Don't assume that that's turns it into 1 over something. So that's why I like the word arc cosine better, because it's not able to be confused. So let's do some of these. So let's say we have a situation where we have a 40-degree angle, a 90-degree angle, and that would mean that this angle here would have to be 50 degrees, because 40 plus 50 is 90, and then the other 90, and that equals 180. So in this case, we don't have any idea what the lengths of the three sides are, because they could be anything. So in that case, we can't use any trig functions unless we know a side length. So here we have a side length of 1. So now we've got something to work with. We could say, for example, that if the sine of 40 degrees equals y over 1, this would be our y, which is our opposite, because remember, sine is opposite over hypotenuse. So here's the hypotenuse, 1. So the sine of 40 equals y over 1, sine of 40 degrees. We don't know what the sine of 40 degrees is, so we use our calculator or tables, and we say the sine of 40. And we have to say degree, and then we evaluate that, and it says it's the sine of 40 degrees. So what can we do about that? That's not very helpful. Well, if we put a decimal in there, then it will force it to give us a number. So the sine of 40 degrees is approximately 0.64. Okay, so 0.64. 0.64 is equal to y over 1. That means that y must equal 0.64. So y is equal to 0.64 units. If this is 1 and this is 0.64. Well, that makes sense, because the hypotenuse is always the longest side in a right triangle, and all these trig functions pertain only to right triangles at this time. So that's how we use the trig functions. But the inverse trig functions, we may have a situation where we have a triangle. And let's say our triangle is like this. And we know side lengths. So let's say that this is 3 and this is 4. And then we know this equals 5. We know that because 3 squared plus 4 squared equals 5 squared, a Pythagorean theorem. So what is the side line, or what are the angles? So the angle here, we'll call this angle theta, and we'll call this angle gamma. So we can't really do anything. We can't say what the sine of theta is. So maybe we'll do this. If we know that we do know that the sine of theta equals 4 over 5, but that still doesn't give us theta. That gives us the sine of theta. So that's where we have our inverse trig functions, or our arc sine in this case. So the arc sine of 4 over 5 equals theta. Now, how do you calculate arc sine? Well, for numbers like 4 over 5, we really don't have any choice but to go to the calculator. And the calculator has tables built into it that will tell us what the arc sine of these ratios are. So for our purposes, we're always going to use the calculator for arc sine, arc cosine, arc tangent. So we go into our calculator and we say, what is the arc sine of 4 over 5? And we know we need to put a decimal in there to get a number out of it, and we get this value, which is in radians. So to convert that to degrees, we know if we want to convert radians to degrees, we say we have, let's see, the number was 0.93. So 0.93 radians. Well, this angle here is 0.93 radians, which is perfectly good answer if your question is to be answered in radian form, which most scientific applications, especially physics, are going to expect things in radians. But we want to see if the theta actually makes sense, and for most people, radians are hard to relate to. So let's see. We have pi radians, and pi radians is the same as 180 degrees. So all we have to do is multiply this number times 180 and divide by pi. Well, in Mathematica, it's even easier. We can just divide by the word degree, and we get our answer. It's 53.13. Now, we could have done that just as easily by saying the sine of 40 degree, paste that here, and then we could have multiplied it by, we could have multiplied that times 180 over pi, and we would have gotten, oops, let's back up here, we've got a little error. Good time to say, the brackets aren't matching here, so we'll come back and we'll put in this bracket. Now everything's black. We can evaluate it, and we get 36 degrees. Okay, so that equals 36, approximately 36 degrees. So 36.8 degrees. 0.8 degrees. So if we erase this guy, put him over here, 36.8 degrees. So let's do one more of these, and